Hi guys, welcome to Unit 9, Lesson 1 Notes on Graphing Quadratic Functions. By the end of the day, you'll be able to graph quadratic functions. So that's super fun. Let's just jump right in. So let's talk about a shape. A parabola is a graph that's shaped like an arch. So it's either going to open up and look like that kind of deal, or it's going to look like that kind of thing. And that was actually a really bad drawing, but that's okay. We'll show you some actual graphs. So if you have a graph that looks like a parabola, that can be modeled by what's called a quadratic function. Now when you have a quad, like if you go quadding, you'll think of a 4x4 kind of deal, because that's what quad means. If you walk out to the quad, a quad is a square. So a quadratic function is anything that has x squared, or rather it starts with x squared. So a quadratic function looks like y equals x squared plus x plus any number. We're just say that constant is c. And we're also allowed to have numbers out in front of our x squared and our x, so we'll say any number a times x squared plus any number b times x plus some number c. So if you have ax squared plus bx plus c, that is a quadratic function. Now, a right here, this a guy, he's going to affect what direction your direction is going, what direction your parabola is going to go. For example, if you have a positive a, that's like if a is a positive number, then we're going to have a parabola that looks like this. What color should I make all my parabolas? I will make them all yellow today. You're going to have a parabola that looks like this. It looks like a smiley face. We say this is a parabola that opens up. So it's like a cup. It can hold things in it. It's happy. It's positive. Aw, yay. Okay. But if a is negative and it's having a sad day, aw, it looks, whoa, I went way out of bounds. It'll look something like that. That was just really bad. Hold on. I'm going to do this right. That was much better. Okay, but still he's negative. He's having a bad attitude, maybe. He's having a rough day. So if a, our number out in front, if he's negative, our parabola is going to open down. So that can't hold water. It's like a hill looking thing. So if a is negative, it's down. We have 2 points that we can worry about. If you have the lowest point on a graph, that's, when it hits its lowest point down there, we call that the minimum, because that's the smallest minimum. Because that's the smallest y is ever going to be. Similarly, if you have a graph that opens down, this number is the biggest that y could ever be, so we call him the maximum. Now you'll notice that this graph doesn't have a maximum because it keeps going up and up forever. This graph doesn't have a minimum because it keeps going down and down forever. Because its minimum is negative infinity, I guess. Either way, these points we call the vertex. So the vertex of a graph that opens down will be its maximum. A vertex of a graph that opens up will be its minimum. So the vertex is this point right here at the bottom or at the top. This point in the middle. The vertex will always lie on a special kind of line. Notice how, hold on. I'm about to do a fancy trick. Notice how this graph reflects over where the vertex is, so it's symmetrical on both sides. Similarly, this graph is also symmetrical on both sides over the vertex lies, like right there. So this line that has symmetry on both sides of that, we have a super fancy name of that. It's not a line, it's actually an axis. I was about to make a joke, but it didn't work. Okay, axis of symmetry. So parabolas will always have a vertical line. It will always go up and down, and it will always go through the vertex. Do I need a new picture of that? Yes, I do. Okay. So no matter what way your parabola is going, let's draw one that opens up, I guess. Yay. Okay. The vertex will always be on your axis of symmetry right here. Super, right? And you can find the axis of symmetry using this formula. Well, I'm gonna give you the x, and then the y will change, but I'll tell you how to get that later. So to find the x value, because this is the line x equals something, it's a vertical line, which is x equals, and that will always be negative b, this guy, divided by 2 times a. So that's a key idea. Memorize it. Love it. Your axis of symmetry is x equals negative b over 2a. So in fact, I'm gonna duplicate that because that's a handy tool that will help us later. Ta-da! Okay, sweet. Okay, that's all the information we need. Now let's put it into practice 3 times. One of the nicest ways to graph any function is just to pick some x's, plug it into your formula, and see what y you get out. So let's do that. Here we've got our quadratic function. We know it's quadratic because it has a square in it. So we'll pick some x values, plug them into x squared plus x plus 4, and see what y we get out of that. Now, if you're going in this blind, because you have no idea what this looks like, it's always a good idea to pick some x values that are negative, pick easy numbers like 0, and pick some x values that are positive. I like to go with easy numbers, so let's try negative 2, 1, 0, 1, and 2, and see where that takes us. So since our x values are these guys right here, let's plug them in. First, if our x value is negative 2, we're going to plug in negative 2 squared plus negative 2 plus 4. Now remember that negative 2 squared is negative 2 times negative 2 gives us a positive 4. A 4 plus negative 2 is 2 plus 4. Oh shoot, it's minus. It's like I'm getting the wrong answers. This is a minus guy. Minus, 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 minus. Okay, that makes a lot more sense. Whew. This comes about to negative 2. Now let's plug in a negative 1. Negative 1 squared is a positive 1, because that's negative 1 times negative 1, plus a negative 1 is 0. Minus 4 is minus 4. Oh, 0 is very nice. 0 squared plus 0 is still 0. Minus 4 is, hey, negative 4. And then we keep going. And we get 1, negative 2, and 2, 2. Cool. Sweet. Now we need to make our graph. Typically, it's easy to put your x and y axis right in the middle of your graph paper, but you want to use your space well. So let's look at our x's. Our x's need to, let's look at our domain. Our domain is all our x values, and that needs to go from negative 2 to 2. So in this whole space, I know, okay, I want to go all the way to negative 2, all the way up to positive 2. So I'm going to go ahead and spread them out a little bit. That's fun. And then my y's, my range, is going to go from negative 4 up to 2. So that's not as big. So I'm going to scoot this guy up a little bit. we need to go, oops, all the way down to 4. Can we still go every other? 1, 2, 3, 4. We can. Okay. -4, -3, -2, -1, 1, 2. Sweet. Okay, this is going to be really fun. Now we have our points. We have -2, -2. Okay, cool. So I go, I'm going to get it blue so it stands out. So over -2, down 2. And then I have -1, -4. So go over 1, down 4. And then I have 0, -4. So put a point right there. In fact, this is going to get kind of messy, so I'm going to erase that so it looks better. And then we've got over 1, down 2, and over 2, up 2. And here's our graph. And now we can connect it with the U shape, that parabola shape, that arch shape that we need. Whew. There it goes. There's a parabola. How fun was that? So fun. So you can plug them in with X, Y, and that's great. Or a better way is to start with your axis of symmetry. So your axis of symmetry is going to tell you where's a good point to start your graph at. So here, our axis of symmetry would be at actually -1, sorry, not -1, -1/2, because it's the same on both sides of these guys. And that would have told us what are some good x values to pick. So let's start here. We're going to use our formula, x equals -b over 2a, to find our axis of symmetry. Let's do that first. So here we've got y equals ax squared plus bx plus c. What is, oh, guys, we don't have a plus c, but we do. Our plus c is plus 0, so our c is 0. Okay, so -b minus 2a. Our b here is 1. And our 2a, our a here is 3. So we have -1 over 2 times 3 is -1/6. Awesome. Okay, so our axis of symmetry is that x equals -1/6. And now we're going to find the coordinates of the vertex. Remember that the vertex always lies on the axis of symmetry. So our vertex is going to be at -1/6 because x equals -1/6. Now we just need to figure out what's our y. If only we had some nice formula here to help us figure out what y equals when x equals -1/6. Oh wait, we do. Okay, so y equals 3 times whatever x is plus whatever x is. Oh, but what is x? It's -1/6. Yay. And without much further ado, this works out to be -12. So our vertex is fun fraction numbers. We're at -1/6, -1/12. Sweet! So we know where to start our graph. And now we need to pick some points around it. So we're going to make an XY table again. And you always want to have 5 points. So go 1, 2, 3, 4, 5. But we know the middle of our graph is going to be where x equals -1/6. And we already know that the y there is going to be -1/12. So now all we do is we take, okay, well, y equals 3x squared plus x. We take our rule, we plug our x's into it, and we found out what is y going to be. And you know what, guys? For your x's, just use easy numbers. We know they need to be around -1/6. So a number that's close to -1/6 is -1. That's going to be easy to work with. Let's go with that. Also, 0 is going to be nearby. Let's work with that. What are some other nearby numbers that are going to be simple to work with? Well, -2 is going to be great. 1 is also fun to work with. We could do an easy number like 5 if you wanted, or 10 or 100, but that's getting kind of out of control. So we'll keep it tight here. Alrighty, we already know what happens when we plug in -1/6. That comes out to -1/12. So if we plug in -2, that gives us 3 times -2 times -2 is 4. 3 times 4 is 12. 12 minus 2 is 10. When we plug in -1 squared, 3 times -1 squared is 1. So 3 times 1 is 3. Minus 1 is 2. Oh, this is nice. I love when this happens. Watch this. 0 squared is 0. So times 0 times 3 is still 0. Plus 0 is still 0. And then finally 1 squared is 4. So 3 times 1. This is also 3 times 1. 3 times 1 is 3. Plus 1 is 4. Yay! Now let's look at our domain. Again, typically we would want to make our graph just kind of right in the middle of our graph paper, but we also want it to fit well. So look, our graph will go from -2 up to 1. So we can actually scoot this guy over a little if we wanted to, because our x's are more negative than they are positive. Sure. On our y's, we only dip down into the negatives just a little bit, but they're mostly positive. So we're actually going to need a lot of space to go up, but not a lot of space to go down. See if I can get this to line up right on my graph. Nice. Okay, we need to go all the way up to 10. So what happens if we go everyone? 1, 2, 3, 4, 5, 6, 7, 8, 9. Ha! Perfect. Okay, sweet. So that means this would be -1, -2. So we have -2 over -2 up 10 gives us a point. Oh no, I lied. We should graph our axis of symmetry first. Our axis of symmetry is that x equals -1/6. -1/6 is going to be a sixth of the way between 0 and 1. So it'll be halfway. Nope, it'll be a third of the way between 1 and 1/2. So 1/6 is going to be like here. So if we want to make an axis of symmetry at -1/6, we should draw it up this way. Good. Now if we do this right, our parabola will go right around that line. So we have over -2 up 10 gives us here. Over -1 up 2 points us here. Over 1/6 down 1/12 is just tiny little baby underneath there. Over 0 up 0. And then over 1 up 4. But check it out, you guys. This is an axis of symmetry. So we can make the same distance over to the other side of our graph. So that tells us we have another point right there to connect with. Isn't that great? We can do the same thing the other way. We can go all the way to our axis here, and we can reflect on the other way. I wish the app that I'm working in right now was able to actually mirror things, but it's not, but that's okay. Oh, one more mirror to do. So what we're doing is we're reflecting from this line over to this dot right here, and we're measuring that same distance over here, which tells us we have another mirrored point right there. Oh, shooties my goodies. Haha! Isn't that so cool? That's so cool. And now we can draw our parabola. And it's not perfect, but it's okay. We do our best. We put on a smile and say, you know what? I tried. It's kind of a funky looking smile. Oh well. Speaking of funky, let's make some funky windows. So let's say an architect is drafting, that's designing windows for a building. These windows are going to be parabolic. Their shape is a parabola, modeled by this equation. H equals -x squared plus 49, where h is the height of the window and x is the width in feet. Let's graph this function. Well, let's figure out what is its axis of symmetry going to be. Its axis of symmetry is going to be, oh shoot, we need to pick x values near the vertex. Sorry, I forgot a line. Okay. So our axis of symmetry is going to be at x equals -b. We have no b value, so -0 over 2 times a. A is -1. But that's okay, 0 divided by anything is 0. So our axis of symmetry is at x equals 0. So let's make ourselves a cute little xy chart. Oh, it's not y, it's h. I'm sorry. X, h, which is going to be our y in disguise. Okay, anyway, so we got x squared minus 49. We're going to start around 0. 0 squared minus 49 is, oh, sorry, it's plus. -x squared plus 49 gives us a 49. Let's do easy numbers. Let's do 100. So -10. Got -10 squared, which is -100 plus 49 gives us -51. Oh, okay, that was not fun. What about 5? What will 5 do? That'll give us -25 plus 49, which will give us 24. Right? This is what I get for going off script. Yep, I'm good. Okay, cool. And let's pick, oh, sorry, that was negative, but it doesn't even matter. It's going to be the same. And let's plug in 2 more numbers. We can do a +10, which will give us -10 squared, which is -100, plus 49 still comes out to -51. And 5 gives us -5 squared is 25, plus 49 still comes out to 24. Interesting. Guys, let's throw one more in. All this dealing with 49. What if we plugged in -7? -7 squared plus 49 is -49 plus 49, which is 0. What if we plugged in 7? Well, we'd get -7 squared plus 49, which is -49 plus 49, is 0. Oh, check that out. Fun, right? Okay. So if I go 2, 4, 6, 8, 10, on my x-axis, let's see, 2, 4, 6, 8, 10, and oh, we need to go all the way up to 50 basically, because we've got 49. So 10, 20, 30, 40, 50, 60, and we need to go all the way down here to -51 as well. So we've got -20, -40, -60. Now that we've got a domain for our x values, we've got a range for our y values. Let's put it on our graph, shall we? Okay, here we go. Over negative 10, down 51. Over negative 7, up 0. Eee. Over negative 5, up 24. Eek. Over 0, up 49. Wink. Over 5, that's where we're at. Over 5, up 24, that's 6. Over 5, up 24. Over 7, up 0. And finally, over 10, down 41. 51. Okay, and now we'll draw our parabola. Okay, cool. Now let's go back to the original problem. It says an architect is drafting windows. The shape is a parabola modeled by this equation where h is the height of the window. It doesn't make sense to have a negative height, does it? So our actual window is going to be wherever our height is positive or non-existent. So our window is going to be modeled by this area right here. Here's our window. You can tell because it's blue. I'm just kidding. You can tell because it has height. That makes sense. You can't have a negative height. Okay, so if you start at the middle of the window and you go over 2 feet, that window is still going to be over 40 feet tall. If you start at the window and go over 7 feet, that window isn't tall anymore. So we've got 7 feet going this way. We've got 7 feet going this way. What's the base of this window? This base is 7 plus 7, which is 14. Wasn't that great? That answers our last question. You're welcome. The length of the base of the window is 14 feet long. And what is the height of each window? Well, how tall does each window get? 49 feet. That's super fun. All right, for parabolas will always take the shape ax squared plus bx plus c, and your axis of symmetry can be found here. Make your graphs around your axis of symmetry, and have a fantastic time on your homework.